Hi everyone, welcome to virtual lesson number 26, and this is our intro to probability. What is probability? So the good news is that some things that you learned last lesson is directly related to probability. So for example, the term event, outcome, all those different words that we talked about last class relates to probability. Now, specifically, the probability of an event is determined by the number of ways it can happen versus the number of possible outcomes. A very common example is a 50-50 chance, so flipping a coin. There's a 1 in 2 chance of you flipping or getting heads because there's only one way to get heads, and that's landing on heads. But there's 2 possible outcomes, heads or tails. Excuse me. In this example was the probability of selecting a heart from a standard deck of cards. So the total number of hearts over the total number of cards. Well, there's 13 ways to get a card that is a suit of the heart, but there's 52 cards total. When you simplify that fraction, it simplifies to 1/4, which converts to the decimal 0.25, which it can also be referred to as 25%. It's important to understand that you can talk about probability all of these ways, okay? You can talk about it like a fraction, a decimal, a percent. You can even use a verbal description to describe the probability, but more commonly we see it either as a fraction, decimal, or a percent. So let's take a look at these examples. You toss a coin and it lands on tails. Well, when you toss a coin, like I already mentioned, there's only one way to land on heads. So that's our numerator in the fraction over all the possible outcomes. The only possible outcomes is a coin landing on heads and a coin landing on tails. So that means there's only 2 possible outcomes. So the probability of landing on tails is 1/2, which can also be written as 0.5, which can also be written as 50%. Okay. Number 2, the letters in the word soccer are put into a bag and drawn randomly. What is the probability of choosing the letter C? So there are 2 C's in that list because there's 2 C's in the word soccer. So that's our numerator over the total number of letters, which is 1, 2, 3, 4, 5, 6. Okay, this can be reduced. 2/6 is the same thing as 1/3, which could be written as the decimal 0.3 repeating. So you can also kind of represent that as a percent. However, in this case, 1/3 is a much easier way to talk about it because it's a repeating decimal. Number 3, spinning the spinner and landing on yellow. If you notice, the spinner does not have the color yellow, so it's impossible to land on yellow. So the number of possibilities is 0. And the total number of outcomes is 3 because there's 3 different colors. And when you simplify this fraction, you get 0. So the probability of spinning and landing on yellow is 0. Number 4, you randomly choose one hat from 3 green hats, 4 black hats, 2 white hats, 2 red hats, and 1 blue hat. So let's just quickly talk about that total. If there's 3 green, 4 black, 2 white, 2 red, 1 blue, you just add those numbers up to get the total. So 3 plus 4 plus 2 plus 2 plus 1. Just wanted to give you a minute to try to figure it out yourself, but 12 is the correct answer there. Now, 12 is always going to be the denominator in this equation because that's the total number of outcomes. So choosing a red hat, you just need the number of red hats. And in this case, the number of red hats is 2. And this simplifies to 1/6. So the probability of choosing a red hat is a 1 in 6 chance, also known as 1/6 probability. Probability of not choosing a green hat. So that means all of your possible options is everything that's not green. So take away the 3 green hats and you're left with 9 possibilities. So it's 9 over 12. And then that can simplify to 3/4. So your probability of not choosing a green hat is 3/4, also known as a 75% chance. And then your probability of choosing a black hat, well, there are 4 black hats. So 4 out of 12, which simplifies to 1/3. So your probability is 1/3. Okay. Now let's take a look at the classic example of rolling a dice. So just a reminder, the possible outcomes of rolling a dice are 1, 2, 3, 4, 5, and 6. Those are all the possible outcomes. What is the probability of rolling a 3? Well, the only opportunity you have of rolling a 3 is once. So that's a 1 in 6 chance because there's 6 possible outcomes. What is the possibility of rolling a number greater than 4? Well, 5 and 6 are both greater than 4. So that's 2 possibilities out of the 6 total. But this fraction can be simplified to a 1/3 chance. What is the probability of rolling an even number? Okay, so 2, 4, and 6 are all even numbers. So that's 3 possibilities out of the total of 6. And that fraction simplifies to 1/2, which we tend to say is a 50% chance. Okay, our last set of examples. The table shows the results of a survey where people were asked about their preferred method of grocery shopping. Use the table to right to sort the statements as true or false. Okay, so in this table, you see that 28 prefer in-store, 14 prefer pickup, and 7 prefer delivery. I think given this current state, maybe it would have been a little higher for delivery, but this clearly were numbers based off of the past. So taking a look at letter A, a person is 3 times as likely to prefer in-store shopping than delivery. So take a look at the 2 numbers, 7 and 28. 7 times what gets us 28? 7 times 4. So that means a person is 4 times as likely to prefer in-store shopping than delivery, not 3 times. So that means A is a false answer. Okay. B, the probability of selecting a person who prefers delivery is 7. So in order to figure this out, we need to know what the total number of people surveyed was. So you have to add 28 plus 14 plus 7, and you get an answer of 49. We know that 7 people in total said they preferred delivery. So that's 7 out of 49 people. And this does, in fact, reduce down to 1/7. So B is a true statement. A person Part C, a person is 2 times as likely to prefer in-store shopping to pickup. So comparing those two numbers, we have in-store shopping is 28, pickup is 14. To go from 14 to 28, we would multiply by 2. So this is correct. A person is 2 times as likely to prefer in-store shopping to pickup. So C is true. D, the probability of selecting a person who prefers pickup is 2/7. So 14 out of the total 49 people prefer pickup. And this fraction does reduce to 2/7. So D is also true. And then finally, E, a person is 2 times as likely to prefer delivery than pickup. So looking at delivery and pickup, a person is 2 times as likely to prefer delivery than pickup. So your gut reaction might be to say this is true, but you have to read it carefully. It's claiming more people prefer delivery than pickup, not the other way around. So they're saying delivery is 2 times more than pickup. But we know that pickup is 2 times more than delivery. So based off of that very slight difference you might not have seen at first, E is false. All right, so that's our introductory to probability. If you have any questions, please let me know.